could pop your video off if you want. You don't have to. You can keep it on too. But my name is John Pattison Williams, and I'm the coordinator of the PHJV Policy Committee. And, you know, my pleasure to see you all here this morning, and also for bearing with me on the experiment to get sending this invite out via Google Calendar. Hopefully it didn't spam you too much, but it worked all right. So today we're going to be hearing the third and final installment of webinars from Prairie Water, the research program at the University of Saskatchewan. And so we have 4 presenters today, Dr. Helen Bulk, Dr. Grant Ferguson, Dr. Chris Spence, and Dr. Colin Whitfield. And we're really pleased to and looking forward to hearing how they're going to wrap up, sharing with us about their research program, and also hear some input, as Ian insinuated there, or inferred. And so we look forward to, if you feel like you want to share and engage today, there's opportunity to do so. Okay, I'll turn it over to the team, and thank you very much.
All right. You can see my slide okay?
Yes, your slides look good.
Excellent. Okay, thank you. All right, so yeah, thanks, John, and the rest of the PHJV crew for having us back. We've really appreciated the opportunity to give a series of webinars this fall. And for those of you that didn't join us in the previous webinars, the first one was really focused on trying to give a recap to an extent of the types of activities that we've pursued and some of the results that are emerging from our work. And the second webinar in October was more focused on how we're trying to take that knowledge and generate some tools that might be usable by different organizations or groups or individuals. And today we're going to try to focus on a more of a dialogue approach to understanding how the types of science that we're using might be used, and maybe getting into a little bit more of strategizing about how to translate the type of work that our group is doing or others are doing, and try to use that in the decision-making process. So we've got a bunch of questions, as mentioned off the top, that we're going to throw at you and ask you to give us some answers to, but certainly we'll have room for questions at the end of the talk today as well. So before I get any further, I just want to acknowledge that I am joining today from Treaty 6 territory, homeland of the Métis, and so I pay my respects to the ancestors of these lands. Okay, so this is the kind of the broad overview of what we're going to do today. I'm going to start by giving you a little bit of background on Prairie Water and the types of things we've been working on, and the types of questions we've been trying to answer. We're also going to have a conversation on water myths in the prairies and how some of our work links to those myths, some of those myths that we're aware of anyways. And then we're going to transition into more of a discussion thinking about what narratives are out there and how we can perhaps use narratives or leverage points to try to mobilize the knowledge we have in the decision-making process. So of course, we live in a unique part of the world, a unique part of the country, and this is a region of extremes. And so we often have conditions where we have too little water or too much water, and rarely have just about the right amount. It's also a region of extremes in terms of the temperature, both seasonal changes, but also what we might experience in any given year. And this poses a number of challenges, both to water management in the region, but also just for those of us that live here. And so when we started this project, we were thinking about how do we take what we know about water resources in the prairies, and how do we understand how the actions that we take today might influence these resources in the future, and how we might transform or think about governance of these actions as a way to mobilize change. And so really what we're thinking about, we've always had a culture of adaptation, but what we want to think about today is how can we develop critical adaptation strategies with respect to the changes that we're seeing on the landscape and anticipate and be prepared for future changes that might come, be it associated with climate change or other stressors or changes in practices of how we manage the landscape. So just to recap, so Prairie Water, our team, there's about 20 of us as kind of the core investigators and a lot of students and others supporting the work. We had a long list of questions when we started this work, and we didn't come up with those questions ourselves. These questions largely came from a large group of users, of partners that we've been engaging with throughout this process. So we had questions around surface hydrology, around the water cycle, how the water cycle might respond to stressors like climate change or to drainage, and particularly what the role of wetlands is on this landscape. We also had questions around groundwater resources, so thinking about both shallow near surface groundwater and deeper reserves of groundwater that are used for quite different purposes, and thinking about how these different types of groundwater might be used and whether there's a sustainable opportunity to use them sustainably, both at present and into the future. We also have been looking at the question around wetlands, trying to identify which wetlands are important to keep. And so we started off with this question of what wetlands must we keep? And I think we've evolved our thinking here perhaps to frame this a bit differently in terms of which wetlands can we afford to lose, given how integral they are to the landscape function and the large number of services that they provide. And then we also have been thinking about the governance. So a team of researchers thinking about these decision-making processes, policy development, what information ends up being used, what informs these decisions, and how do these processes vary across different users. So as I mentioned, we've been engaged with a large group of partners. So particularly in the last number of years, we've been engaging with groups like yours through webinars and other activities to try to share the types of information we have. We're broadly organized across 3 different teams: water availability, aquatic ecosystem health, and water management practices and governance. And it's really important to us that the types of research that we do and these types of questions that we are trying to answer have value to those that are working around water resources in the region and beyond. And so our overarching goal here is to help build resilient communities by ensuring sustainable watershed management and governance on the Canadian Prairie. So one of the things we've done, so this will highlight some of what we talked about in webinar number 1. One of the things we've done through our work is to try to better understand the types of watersheds that exist in the prairies. And so we performed a classification exercise using about 4,100 small watersheds of about 100 square kilometers and trying to distinguish these watersheds into different classes that we would anticipate to share different characteristic behavior. And so we're using these different typologies or these 7 different classes to try to infer what's happening more broadly across the landscape. And this gives us a nice opportunity to build on what we know from some of the large research basins that we have a hard time generalizing spatially from. And so this is a key plank in our approach. And I will next ask my colleague Chris to share the next few slides with you.
Thanks, Colin. Hope everybody can hear me all right. So in order to answer a few of those questions that Colin showed a couple of slides ago, we needed a general approach as he sort of said, to generalize away from the research catchments and other places to answer some of that, to figure out, to get some general estimates of how different climates or land use choices might influence water budgets. And so we took this virtual basin modeling approach, where we built in a hydrological model for each one of those 7 classes, sort of a virtual basin or the typical basin. So we used terms from or variables from the classification, like slope, soil type, wetland distribution, and built this sort of prototypical virtual basin of, say, a high elevation grassland basin or a pothole till basin. And from that built a model and then simulated it over, or applied climate to it and simulated sort of over a long period of time, say it's 30 years, to figure out what a regime would do if the climate warmed up, for instance, or drained wetlands, for instance. I think you might have to advance the slide. So, and something else I should note about the virtual basin modeling is that because it's a generalization of a generalizing approach, the results we get aren't for any particular place. They're sort of for the average watershed that would occur in that type, or for the region as a whole. So kind of think of it as we're modeling nowhere in particular, but everywhere, if that makes any sense. And so what we can do, if we can go to the next slide, sorry, is what we would also like to do and have done is integrate different models. So we can take the hydrological model outputs and feed them into different types of models, nutrient transport, in this instance, biodiversity, where we look at different wetland drainage scenarios and say every 10%, what does that do to the pond water budgets? And in addition to, what does it perhaps do with due to the biodiversity? So you can see where removing wetlands on the landscape sort of has this non-linear result on biodiversity, where if you pull out the first 20% wetland area, you lose about half of the riparian bird abundance. Anyway, next slide, then, Colin. So further on top of that, some of the other things we've done is, this is Christy Morrissey's work and a postdoc of hers, Agina Malaj, where they developed a pesticide occurrence index using these 4 different inputs: wetland density, precipitation, some physical chemical properties, and pesticide use, to come up with this index, which you see on the right in the sort of the blue to red, red being sort of a higher index of pesticide occurrence in wetlands. And what we'd like to be able to do with this is link this index to the virtual basin modeling, where we, instead of precipitation, perhaps we put in runoff, and then run different scenarios through that, different climate scenarios as well. So that might be it for me for now. Next, yeah. Anyway, thanks.
Thanks, Chris. And yeah, so one of the things that we've been encountering through our work and getting out and having conversations with a wide variety of different individuals and organizations is that we hear some of the same myths when we present our work. And so we thought it would be useful today to have a little bit of a conversation about the myths, not only that we encounter and how science that we're doing contradicts those myths to some extent, but also to understand the myths that you would encounter in your work. And so obviously there are reasons why myths exist and have the presence that they do. So some information here put together by our colleague Graham Strickert, who was going to join us and was unable to join at the last moment today, him and one of his students, thinking about the role of myths and thinking about how a long time ago, if we go back to ancient Greece, that distinction between myth and science was not clear. They were kind of embedded within one another. And that last point is perhaps an important one. And when we reflect on the myths that we encounter, being that belief and science are not antagonists if they're centered around a worldview. And I think one of the challenges that we encounter perhaps is some of the worldviews that that link strongly to some of these myths. But we can also think about mythology as a tool. So can we use this to crystallize messages into memorable and enduring form within a value system? And can we use what we understand of myths and worldviews to support decision-making, to help us navigate some of these challenges in different values, perhaps? So we are going to share a link, and that should appear in your chat. And we're going to ask you to contribute to this this link. So it's anonymous, so you can contribute without having it being attributed to you. We want to know what types of myths you encounter in your work, thinking about wetlands or habitat or water more generally.
Don't be shy, folks. You'll see on the first page some instructions on how to use a Jamboard. If you can't get in, you can throw ideas in the chat. But I'll get the ball rolling in my own work on water quality and say one of the real challenges I face is the myth or perhaps misconception that phosphorus isn't mobile, so that phosphorus is fixed in the soil. So that's one that I feel like it's really important to engage in conversation about and see if we can get past. I see no takers though.
Ellen, would it be useful for you to share the Jamboard instead of the slide at this juncture?
I don't know if I'm able to. My screens aren't well set up. Are you able to, Colin?
Perhaps.
Don't be shy, folks.
All right, some things are coming, so that's great. I will transfer over so we can see what others are contributing.
Yeah, these are good, and these are ones we face quite a bit in terms of what is a wetland. That's a really common barrier. Wetlands are wastelands. Wetlands are wet. I feel like folks could put their hand up if they've encountered this one.
They're excellent.
It was mysteriously disappeared.
Yeah, I'm not sure if there's a new page started, Helen, or
Nope, I don't know what happened there, but that's okay. Maybe we should go to the ones that we chatted about.
Yeah, for sure. And thanks everybody for contributing those ideas. I think it gives us a really excellent representation of some of the ideas that are out there that we struggle to get past sometimes when we're sharing our understanding from a scientific perspective. Okay, they're back. That's good news. We didn't lose them all. All right, so we're going to walk through 3 different myths that are often part of the conversation when we are sharing our work. So the first one, Chris will lead us through. Oh, and you can't see that yet. Let me figure out why my buttons have not worked. There we go.
There. Yeah. So I'm not sure if many people have come across this one, but I certainly have, and that draining wetlands don't increase surface flows or surface runoff, stream flow, what have you. I've encountered this before. It's incredibly difficult to disentangle the role of land use and climate when looking at time series of stream flow in large rivers like say the Assiniboine or the Red or the Qu'Appelle, and say this is the signal from wetland loss, or this is the role the wetlands played in any given flood that happened, say 1997 or something like that. So it can be difficult. There's a myriad of different conditions, antecedent conditions that occur, and precipitation that occurs that produce runoff from these from individual watersheds. So it can be tough, and so there's a lot. Even though Helen led a synthesis paper earlier this year that suggests there's quite a scientific consensus that draining wetlands do increase surface flows. But the devil's kind of in the details in terms of like, well, how much and when. And so what we've been able to do with the basin classification virtual modeling approaches is really glean what the loss of wetlands means for different across an entire runoff regime. And basically what we find is a few key takeaways is that, one, there is no threshold below which drainage doesn't increase surface flows. So as soon as you start draining wetlands, there's an enhancement of flows. The other thing that we find is that the response really depends on the conditions over an entire regime. So average years tend to be impacted the most, dry years the least, because if it's dry and it's raining and depressions are empty, there wouldn't have been much flow to begin with, and the fact that you've drained that there has been wetlands drained doesn't mean much. And then in the other extreme, in the wet years, it was already super wet to begin with. So while there is an enhancement of flows, it's say not as much as the average flows. So that's one of the, and this is all summarized in a recent paper that just came out. So I'll stop there. Thanks, Colin.
Grant will walk us through the next.
Okay, so yeah, I'm not sure. People think about groundwater all kinds of different ways. So maybe this isn't how other people have thought about it, but it certainly is something that we've that I've heard is an approach, and certainly we've seen it other places in the world, right? That we run out of surface water. Stream flow isn't there for whatever reason. We use too much climate variability, and the response is, well, we can just use groundwater, and that'll be an approach that we could use to increase water security, right? So this was, I guess looking to our south, right? This is what happened in the high plains of the United States in places like Kansas and northern Texas, as a response to the dirty 30s and the Depression, right? Irrigated agriculture, all supported by groundwater, and it hasn't worked out so well. So I guess wrapped together with this myth is this idea that the water budget can solve all these problems, right? And we use this approach within Prairie Water, and one of our big outputs has been some really good work by Masaki Hayashi at University of Calgary to map out what groundwater recharge might be across the prairies. And the problem we've come up against now that we've finally got back out to the fields after some stalls during the pandemic is when we look at the water in some of our aquifers, and I've done a lot of work on deep aquifers, like really deep, for those who follow the Prairie Water program. But this data here is actually coming from, I guess, what we call shallow aquifers, aquifers that people would be using for water supplies. So thinking, between maybe 20 and 80 meters deep, right? So not ridiculously deep. I mean, the sort of depths that a lot of wells in the Prairie provinces are installed to. And we got this data back, and it still needs to be polished and corrected a little bit. But we looked at radiocarbon concentration. So the same way that an archaeologist would date something, from ancient Egypt or some other artifact, right, to tell how old it was. We can look at the carbon that went into the water, into the ground, with infiltration, and basically the clock starts ticking then, and you lose radiocarbon as it decays. And the waters we're seeing in these relatively shallow aquifers, it's anywhere from a few thousand down to the point where we can't even see the radiocarbon anymore, which is after it goes through a few half-lives. So more than about 40,000 years. So that's going back quite a ways in time. So I guess that brings up a few questions, right? I mean, clearly that's not water that was recharged in some of Masaki's work that happened last spring or a few years ago. So if we use that, how is it going to come back? And I won't say it's as simple as it won't come back, because once we start to pump water, I mean, flows can change directions, and we can have odd impacts on how the hydrology works beneath our feet. But it doesn't look overly promising, right? That we have last year's water flowing through, and we can always expect that to be replenished. So I think that's an interesting outcome, right? That the waters beneath our feet is potentially tens of thousands of years old, right? And I'm not talking about waters down near the center of the earth or whatever. I'm talking about waters that are a few meters below the water table in some cases, buried beneath clays and glacial sediments. So that was, I guess, a myth I've come across, and I'd be curious to hear people's takes on that.
Thanks, Grant.
And I'll speak to this one. This is one I often hear, that because wetlands are often phosphorus rich, they're the source of nutrients to streams. So by extension, some would argue that draining wetlands will improve water quality. And indeed, the opposite is true. Wetlands are phosphorus rich because they act as small traps of phosphorus in the landscape, catching that phosphorus from upstream. So they can retain and often re-release it, but they didn't create it. And our estimates suggest, as shown in the plot here, and these are conservative estimates just for one basin type, that by impacting flow alone, complete wetland drainage could more than double phosphorus exports. So an impact that really couldn't be mitigated in the landscape. So now that we're good at Jamboards, we wanted to ask you another question, and I'll hit enter. This is the third Jamboard. You'll see an image that looks like the snapshot in the right-hand corner. But the question we have is, what methods do you use to overcome myths or build support? And again, if you prefer the chat, feel free to go ahead. Some good ones coming in. So listening to stakeholders, dialogue, storytelling, digging into the science. Yeah, Marie mentions in the chat trying to find out why a person has that belief. And I think that's really important, is getting to the root of where the beliefs are coming from. Focus on the problem being faced, share resources and finding solutions. So this idea of common problems, common solutions, and working together in a team is incredibly powerful. Two-way communication, absolutely. Sort of the loading dock model of, if we have all the science answers and drop them on your doorstep, then you'll be able to solve the problem, is very much incorrect. So this two-way communication, listening, working together, is clearly a better way. If you haven't put a stick it note on, feel free to go for it. You'll feel powerful. All right, I'll return to our slides with Colin's help. And sort of just to recap, we've gone through briefly the story of Prairie Water and how the work has been informed, how the work program has really evolved. Talked a bit about water myths on the prairies, and I think your comments on the Jamboards have really touched on many of the things we've also been learning, including the importance of different narratives, and then an idea that's gaining a whole lot of traction, I think, in the sustainability literature, of this idea of leverage points. So first, I'll mention, through my work on water quality and on wetland drainage, I found that the framing of a problem matters a great deal. So that's the idea of, how are you presenting the problem? Is it, are you being critical of producers and creating a problem? Are you presenting it as a collective problem where we're all facing it and trying to solve it, and so on? There's a great deal of sensitivity we all feel when we're criticized, and producers aren't unique. So this idea of social license to farm being seen as doing the right thing is very important. And that idea of feeling criticized is inherently unhelpful if you want to try to get people on board to do the work that you think is important. So the framing that I've gravitated towards is this idea of a wicked problem. And we've been able to characterize wetland drainage is a wicked problem, ultimately impossible to fully solve. There are many stakeholders with different goals, different definitions of the problem. Even the definition of wetlands, as mentioned, is contested. Some people don't see ephemeral wetlands as wetlands. The solutions to the problem, or even how a problem is perceived, varies from year to year. When it's dry, wetlands on the field really aren't a concern. When it's wet, there's a big push to drain. So, the definitions, the goals for the landscape, those are contested and really varied. And then the images at the bottom show some of our work working with academic scientists and producers to understand how they think the system works. So these are examples of a map of how one scientist and one producer sees the system around wetland drainage working. And certainly the choices we make and the choices we want to see made are informed by many things. Those include our goals and our values, but they also relate to our own understanding of how that system works. And why I find this helpful is because it reminds me, as a natural scientist, both to recognize the wickedness of the problem, so that this is, a very complex problem, but also reminds me that we see things differently. So going into a dialogue with a humility to say, I don't know your land and how it works, But hopefully if we talk this through, we can understand and end up on the same page, at least about many of the important things around wetlands, around drainage, around your own operations. So those, these maps and the dialogue that's come with them has helped me see ways forward to countering what I see as some of the important water myths that affect decision-making. So once again, we have a couple discussion questions for you. And these are in the Jamboard number 4. And those questions are, what narratives matter for achieving habitat protection? And what information is effective in changing minds or changing narratives? Harder questions, fewer sticky notes so far.
I think the link was slow to appear, Helen, so I'll give it a moment or two.
Yeah, consideration of opportunity costs. Huge one. How does habitat protection link to personal identity? That's interesting and important one too. That disappeared, but it'll come back. One that I find interesting is how the framing of the goal matters. So things like wetlands as tools to prevent flooding versus wetlands as biodiversity conservation hotspots. Yeah, and that speaks to the comment there, need to talk and find out about what matters to people. Sometimes it doesn't. So in many ways, looking at all of the different ecosystem services provided by wetlands can allow you to find a framing that resonates with people, although certainly those opportunity costs are also pretty hard to get past.
Yeah, and Murray's commented in the chat here as well. Often habitat is considered a waste of space or a problem to our lifestyle. And I think one of the things we learned in the last few years is that there are maps that classify wetlands as wasteland, which probably helps to reinforce some of those perspectives. I'm not sure that that is a approach to mapping that holds across other provinces. It's certainly the first time I've encountered seeing wetlands designated as wastelands on the land classification.
That's an important reminder that someone on the call will know the answer to, but it's one of the provincial land inventories that still uses that language. So that's an easy thing that we could certainly push to get fixed. Yeah, a value issue, much like politics and religion, not easily changed despite the science. These are great. And we see, you know, culture also is important, right? So people whose families come from, say, the Netherlands, where farming really is corner to corner and has been for long periods of time, you might see messy edges and messy fields as a sign of laziness or, you know, not taking care of the land. So those cultural narratives are so deeply entwined and really important to understand because they affect how a person will respond to you and your science and your advice. Yeah, there's a narrow range of what we consider important in biodiversity, certainly. Who is trusted as a messenger, also very important. And certainly in recent years, we've seen evidence that scientists are not universally trusted as messengers. I do think one of the things that is important, though, is the idea of triangulating messages. And this is why opportunities like today are really valuable, because the more people hear messages echoing across multiple sources, multiple trusted sources, the more they're able to take those messages on board and really believe and act based on those. So I think Colin at Mission Control is now working on our last couple of slides.
There's
but
a
I
new
think
one there that popped in that's maybe worth commenting on. Government doesn't respond to science, but there's lots of inertia and momentum in government policy.
yeah,
Maybe
and that
something important to think about as we go to this next set of questions and ideas.
that is a good segue, and lots to chew on and think about there. We should all have tea in a non-virtual setting soon. So one tool that we're starting to use to try to advance dialogue is scenarios. And scenarios, I think folks are often familiar with. You know, we have IPCC climate scenarios. The scenarios I'm talking about are a little bit different. They try to be very broad and encompassing of the many things that we're thinking about, you know, not just runoff, not just flood risk. So scenarios can be useful for a whole lot of reasons. They can help us understand different futures, alternative futures, work on a vision. So understanding, you know, which futures we consider acceptable or desirable, raising awareness about, you know, the track that we're on, setting agendas for priorities, setting targets, screening policies. This is really important and interesting. In terms of, you know, when we think about provincial agricultural policy, is that aligned with the future prairie that we're aiming for? Scenarios can help build dialogue and ultimately build towards more common goals and understanding. So this is just a note to say, really, this is work that we've started, and really working just on describing a suite of possible scenarios with the hope of moving those into a workshop setting to design, you know, what a scenario might be in a more local landscape, or have people guide towards the scenarios they want and identify how we might navigate our way there. So in the Prairie Pothole region, the scenarios we've discussed to date are agriculture as usual. So if we continue on the same track, where we're going to end up, accelerated agricultural growth, which arguably is the current policy direction, moderate but managed climate change, so investing in climate adaptation, unmitigated climate change, and then ideas of incentive-driven change, and one that is not very appealing to many, but that is regulation-driven change. Sorry. So, scenarios are one tool to think about changing a system that we're in. But the last question we'll leave you with, and Colin, you might have to pick up if I can't talk anymore, but that is, what levers or leverage points can we use to try to develop and achieve adaptation strategies or conservation goals? And this idea of levers and leverage points, as I mentioned, has gained a lot of traction in the literature. And it really just identifies, how do you change a system and how do you change it most effectively? So what are the levers you can use to move the system? And what is the leverage point, which is the area you can target to try to have a disproportionate impact where you can most influence the system?
And with Helen's voice failing there, our next step will be to use a 5th Jamboard here. So Helen will post the link when she's able, and we'll get you guys to share your thoughts on these questions, thinking about these leverage points. that fifth link is there in the chat. So what leverage points do you think could be targeted?
Pay farmers for environmental goods and services. So that's certainly a really important one. It appears to be the only one. Other ideas, folks? So this one, business case, across multiple policy areas. I see this as really important, in particular in terms of roads and floods.
One that I'll offer here, I'm not going to type it in because I fear that I'll destroy the ability to look at these things if I start getting to that level of complexity. But one of the things that I've observed in living in Saskatchewan the last 12 or so years, 11 years, is that there's a real love for lakes in the province. And lately, I've began to wonder whether what's happening in our lakes is maybe one of those ways to understand or to raise awareness for the role of wetlands. So rather than talking about wetlands directly and the importance of conserving them, but making the links of maintaining healthy lakes for our recreation and our property values for communities that live on some of the bigger lakes in the province. That's a thought that I've had. I don't know if it has legs or not, but it's certainly something that I've been thinking about the last number of months.
There's one here that I think, I mean, I agree in terms of lakes. I think that's potentially a leverage point where, you know, if we can't mitigate runoff effects, the lakes are going to get worse. And, you know, a lot of people care pretty deeply about that one. There's a good one here about prioritize land use but ecological value. Convert low value land to ag, conserve high value land. And I think similarly, ideas around converting marginal lands back to more natural uses is certainly an important leverage point where we see, you know, really good policy, really good incentive programs around moving forward there. Lots of good ideas coming in here. I do see this idea of social license as perhaps one of the most influential, as well as growing industry pressure and certification programs coming in, which may also really influence the system.
Okay, feel free to continue adding those ideas, but this brings us to the close of what we had planned for today. So really appreciate everybody engaging and sharing many valuable thoughts. I think it will give us lots to ruminate on and hopefully allow us to continue the conversation as we add a few more nuggets to kind of the scientific questions we're trying to answer through Prairie water and beyond. I will stop sharing that and just bring you to our final slide. And an opportunity for you to ask any questions that you may have. If I can, lost my mouse.
If you do have questions, please feel free to either raise your hand or just ask the question or type it into the chat box.
Maybe you needed a Jamboard for questions, Helen.
Clearly we did.
We're shy. We're shy at the end of the webinar here. Thanks, Chuck. All right, Alistair. Alistair's got a question for us. What's next for Prairie Water and how can we help? So I'll invite any of my colleagues that have helped present today to answer that one.
I don't know, you and Chris are in charge. I think it's a good question and we're coming close to the end of the program. So looking to, you know, what's next and what's needed for next steps on prairie adaptation, prairie resilience, and so on.
Yeah, I guess the funding program, the broader Global Water Futures, is coming to an end, but we'll still be around. It's not like we're disappearing from the university. So we're keen to work with producers, other interested parties in water and the environment across the prairies. So I'm not sure what those opportunities look like, but usually when we can find collaborators such as the others on this call, we can do something. There's funding programs out there that support those sorts of things. But a lot of it has to be, driven by the end users and by the community rather than us if we go with that route. Otherwise, we end up struggling to figure out like what we know what the interesting scientific questions are, but is that actually useful?
I think that maybe Colin can speak to this a little bit after me, but I'm a bit blown away by the size of the data set that we've started to produce, whether it's hydrological outputs, different climate scenarios, and then linking those to nutrient models or pesticide models, all distributed across the prairie. It's a big job for us to try to get that into an accessible form for people, but that is a goal that we have, Colin, I have for the last sort of year and a half, however much time we have, because I think that data, if that could have quite a legacy if we do this right. Cross your fingers.
I think it's an important point and maybe goes back a slide too of what are the levers and leverage points from that data, from the dialogue around that data, from the network that's being built, and people on the call in terms of advancing adaptation and decision making with those new products in hand.
Yeah, I don't have much to add, but I would just maybe to Alistair's question, for me, as one of the leads on this project, one of the most rewarding parts has been just seeing the level of engagement we've been able to affect and the interest from so many individuals in our work, and trying to understand the types of things we're doing and have them be useful. And so Chris raises a good point about, our ongoing effort to try to share this information in meaningful ways, which will be a focus. We've got about a year and a bit left where we'll be at this as a team, but we're certainly looking to move this work ahead beyond the initial tenure we had, the initial 7 years. And Alistair has raised a question here to the audience, which I would be happy to hear your thoughts on, which is, what of the suite of things you've seen over the last 3 webinars and today, what of the questions and the approaches we're taking do you see as priority areas? Because that might be valuable for us to know from the perspectives outside of our group, and identify some of those opportunities to continue to work and to continue to build our collaborative work as we transition to a post Prairie Water or post GWF future.
If you do have answers, any comments on the question that Alistair did have, if you could send it to the answers to John, he can compile them all and forward them on to today's presenters. And I imagine that if anybody's interested, he could also probably make them available, the questions available to everyone else as well. We are right at our end time for today. I'd like to take this opportunity to thank our presenters for an outstanding series of presentations. I'd like to thank everybody for their participation in today's very interactive webinar. And I'd also like to take this opportunity to wish everybody a happy holiday season and a great 2023, as this will be our last webinar for this year. We'll be starting again in January. And if you do have any questions regarding the presentation series, please again forward any questions you have on to John, and he'll be happy to forward them to our presenters. So thank you, everybody, for attending today. Thank you to our presenters, and have a great day.
Thanks, everyone.
Thanks, everybody.